So I'm joined by Paul Senior now
Yep.
from Densair. Paul, give us a little bit of background to Densair and what the company's all about.
So Densair, as the name suggests, is all about densifying the mobile networks so that we can, provide, seamless connectivity. We're focused, if you like, on three different types of areas. One of which is why we're here at Cenex, is what we call the automotive use case. And as we move closer to autonomous vehicles need what I would describe as a connectivity leash. You can't allow it to get out there and not know where it is, not know what it's doing, and potentially having the ability to rescue it when things go wrong. There's lots of stories right now of taxis in San Francisco getting stuck because there was a music concert where there was 1,000 people at it. So we started an R&D program in 2018 to develop that. The initial project was actually part of one of the government's 5G testbeds and trials, which was here at Millbrook, the AutoAir project. We've got a follow-on project which we call CompoRAN, and that is all about building clusters of small cells which work in collaboration with each other. It stands for coordinated multipoint. That basically means, you're always connected to multiple base stations at the same time, which gives us a much higher resilience and robustness in the network.
Here at Millbrook, you've set up a whole kind of system that is separate to the networks that you normally see around sort of a normal town or whatever. Why Millbrook and why did you have to do that?
So we need somewhere to test our radios in the real world. In particular, we need somewhere where there is autonomous vehicles, and Millbrook's one of the few places in the UK where there's active development of autonomous vehicles and validation. We set up these base stations, and again, our goal is to validate it in the real world.
But what's the next stages for Densair then? Is it to take it from here and roll it out?
Absolutely. So again, we're doing a pilot project focused around what we call a high demand density scenario. That means it's a scenario where you have a huge number of people turning up either on a seasonal basis, on an event basis, and of course the networks creak or don't even work in that scenario. So we've got great traction with operators here in the UK, great traction with mobile operators in the US. We're working with the Department of Transport authorities in various states in the US. We're doing the same with DFT basically here to find, those initial projects that we can then scale up. No one today can build this technology on their own. It's all about partnerships and consortiums. You take the building blocks, and it's classic, you're building on top of the pyramid. You're standing on everybody else's shoulders. So what was very important for us was some of these UK government competitions, because it kind of pushed us into forming consortiums with partners that provide us the building blocks that we need. And our job is more than a systems integrator, but we can't build everything from scratch. We're lucky we've got very, very, good investors that own the company now, Sidewalk Infrastructure Partners. They are describing themselves as patient capital. They're not looking for a quick buck. They want to transform the infrastructure, different types of infrastructure, and we're one of the segments that they're focused on. So I think we're going to have enough runway to get to those big commercial proof points, which I think then is the reward that all those partners will get by working with us.
And we've talked about 5G and people are starting to see that coming through on their phones, but this is really true 5G, almost 5G plus, isn't it?
You've got it.
It's better than 5G.
So we decided a long time ago, our intercept point in terms of when we'd be ready was with something which we call 5G advanced, or otherwise known as 5G standalone, where it's a pure 5G network.
And that's really important, isn't it? When you're talking about autonomous vehicles almost talking to each other to say, look, I'm braking, you need to start braking. Yep. That's any latency, any dropout, anything, that's where your safety and your safety critical systems coming, isn't it? And this is why it's so important with 5G Advanced.
And again, that's why we're here, because for that use case, robustness and reliability are absolutely fundamentally what you've got to have. It's not viable to say that 98% of the time that message is going to get through. We're after certainly 5 nines reliability from the networks we build, and I think we're optimistic that we'll get to 6 nines, which means that you can really bank on the fact you're not going to lose connectivity for an autonomous shuttle once it goes down this autonomous laneway.
It's really important for people to understand when we're showing sort of bits of this technology that the real difference here is that the signal is being sent and received to more than one mast at the same time, isn't it?
That's right. I mean, it's again, to get the robustness, it's no longer handing between cell to cell. You're simultaneously connected at all times to up to 4 cells, simultaneously 4. So you have a choice out of 4 rather than a choice out of 1.
How far are you ahead with your actual mass technology and all of that? Are you ready to go?
No, again, first generation, you can see on the poles as we go around here. There is that we call the 1.1 street cell, but we're already, in advanced discussions for what we call street cell V2, which is, a more sophisticated version. We're going to miniaturize it because, this is nice. It fits nicely onto these poles, but we want that technology to fit on every lamppost in the country, or any pole that we happen to have on a roadside. So we're going to miniaturize it. We're going to look for more performance. I guess the other really important thing is network integration with the mobile operators. That's the other thing that we're focused on over the next 18 months. Because without their integration, we can't connect everything. We can focus on the bits that their networks don't reach. And it's all about how you design the network, but you're designing the network in a way that creates that fundamental robustness. Again, this is what comes with the latest generation of 5G, our ability to have that kind of performance and get those kind of levels of reliability.
That's fantastic. Thank you ever so much for today.
Cheers.
Cheers.